Okay, so today we're meeting with Professor Sajitha. Which university were you from again?
I'm from Indian Institute of Science, but at present I'm not. I'm like a sabbatical kind. I'm just building effectual learning
Okay,
here in
effectual
Qatar.
learning. So
Yeah.
that's something that I'm going to learn more about. But we're talking about three-dimensional models and database structures for that kind of information.
Yes.
So if we go here, we're just demonstrating fine-grained access control, and I just took away my access to my aircrafts here. So I'm going to go back to KeyCloak and rejoin a group called admin, and then I'll be able to see my aircraft model here. So, okay, so although we haven't already created a simulation environment like yours where it's showing 3 dimensions for physics shapes, what we do have here is simulations of airplanes in so this airplane is going around the Earth with some coordinates here that are always changing. These are latitude, longitude coordinates. But if you look at the code behind the scenes for aircraft, with spine programming, we generated this API with all the methods to general methods, search API, get, patch, post, delete, import, and then a search page, an edit page, and delete code. And then we can customize this to do additional things like simulate the aircraft over time. So here I've added some additional methods. Normally with spine programming, this class is empty, and it allows you to override the class with whatever extra code you want. And so what we're doing here is allowing us to create a simulation. So if we've set the simulation to true here, we can toggle the digital twin simulation on and off. And if we toggle it off, then the point on the map stops changing, stops going around in circles. If we turn it on again, then these points are always changing, and so is the point on the map here. And where this becomes 3 dimensions is when we convert latitude, longitude, which is the source CRS, to Cartesian coordinates, which I think you're familiar with, which involves X, Y, and Z. And then we go and transform from latitude, longitude to X, Y, and Z on the Earth, because elevation, airplanes have elevation. This is basically just keeping it at sea level, but physics simulations involve 3 dimensions as well. So we use Java to store the location information, and we store this in 2 places. We store it in a database, and we also store it in a search engine. So if I go to my OpenShift container platform in OpenShift local, so this is a Red Hat OpenShift cloud platform running in my own computer. And then I go to workloads, pods, and I switch to the Postgres pod. Then here's my PostgreSQL database. And if I connect here, I do psql-u, Postgres, and this lets me authenticate. And then let's take a look at my databases. So I have a smart aeronautics local. So I'm going to connect to psql-u, smart aeronautics, smart air, aeronautics, local It's a little tricky for me to spell. And then let's look at the tables. So there's an airport table. And if I look at the definition of that, airport, then it has a location that is a point. And then if I do select ID, comma, location from aircraft, or let's see, let's do PK and entity short ID. Okay, so we have a point. This is the latitude and longitude that I was talking about. So to make this 3 dimensions, let's just ask how to store 3-dimensional shapes in Postgres. We have the PostGIS extension, and then you do geometry. Yeah, so you would create a geometry model. And area served. Does this have? Let me do D airport. Okay, so here is an example of a geometry that's a polygon. And this is talking about geometry that's a polyhedral surface. So we're doing very similar things. We just haven't quite gotten into the polyhedron surface kind of geometry and spine programming, but that doesn't mean it can't be done. So the airport model is like this. I have this airport defined, and it has both a point and it also has an area served. So the area served looks like this, and it's type polygon. And then it also has a location that's a point. So let me ask another question. Does GeoJSON describe? Okay, so GeoJSON does not natively support polyhedral surface. So we'd have to find the right way to represent the 3D polyhedral surface, but as JSON. But I don't know. What do you think so far? Because we persist with the aircraft model,
So
we
you're not
persist like
collecting.
this.
One question I have is, you're gathering this as a public from a public APIs, right? These data. It's not like you send your drone out and you're collecting its altitudes and the coordinates, X and Y coordinates, right? It's not like that. Like through a device, you cannot. It's a more collective samples in your programming, not a specific kind, like a student building on a STEM projects, collecting and having a similar 3D model being displayed on something like that, right? That would be too simple for you.
Well, it's not that. With spine programming, you are the developer of your own digital
Okay.
twin, and you can run it locally, just like I'm doing here in my airport digital twin. This is running on my local host port 10280. But we also deploy these digital twins to the cloud, like this one here. smart aquaculture, smack.computate.org. And then if you don't have an actual device that's sending you live updates, then you can simulate it by building your own model and creating your own new airport. For example, like I go and create a new airport, SLC, and create this airport. And then I go to the map and I put this out here, Salt Lake City. Where's the airport? Somewhere out here. So then I can see, move my thing here, set a point, and set the location, and then set the area served as here's my airport.
Okay.
So this is the idea. But yeah, we haven't, and then this goes and persists in the database now. So now instead of one aircraft or airport, there's now two. There's one, there's two, and then we automatically build the API to give you information about this airport here, and a search page and an edit page. And then you can write the code to simulate something if you want. Locally, you would go to aircraft in US API surface simple, or no, that's the example of the aircraft digital twin simulation. You can go to airport in US and implement your logic for simulating that airport, for example. So you can do whatever you want, and you could connect this to live data, because spine programming supports all the major message brokers. So like Rabbit, site routes, no, main vertical, smart aeronautics. So Kafka is Red Hat's message broker. MQTT is a popular one for IoT devices, AMQP, and RabbitMQ. Like, you can pick your message broker and receive messages from your smart device or a REST API if you have webhooks. It's really, you can do whatever you want and then integrate that into your digital twin through a topic. Did that answer your question, or not quite?
So here you are creating the locations and the area, or the program assigns the area of, you're not collecting the real data, right? I was in the impression that you can gather IoTs, like how they do that, right? In Aqua, I was in the impression that this is similar to aqua culture, aqua farming and all, where IoTs are collects and you have AI to, so this is something that kind of a digital twin. I'm still figuring it out what actually spin programming is. I understood that the data structure, you can really make it easy. That part I got it. But how are you getting the data? That I'm not able to, you know? Yeah, is it
Right.
just the simulation, or you are gathering it from somewhere? Yeah.
Well,
Like how
we're
you get, right? Airport, you check when your status of your flight or flight tracker. It's not like that kind, right? Maybe I have that impression in my mind.
right. So we have lots of projects that have potential for getting started, but we're
Okay.
still trying to get approved to launch a smart city project with
Okay.
spine programming. So that's something that's going to happen in the future, but for now we've been showing that we can simulate these kind of environments first with a very secure application that supports zero trust and fine-grained access control and scoped permissions, because smart cities need to be safe. It needs to be trusted AI. So we're not just generating anything we want with Claude code, where we have a framework that's built with security in mind and access control so that it can be trusted. And then we build on smart data model standards, because although me and Dwayne and Denis have not yet integrated our digital twins with live data, this smart data model community has. This is a FIWARE-led program over many years that are building these smart data models with actual IoT devices out in Europe or Africa or other places. So we're integrated, interoperable, and compatible with these smart data model standards. So if you want to follow their patterns, then we're compatible with all that. So if you want to look into it more, you can research how FIWARE has been integrating smart devices out in all kinds of places in the world. And that's where we plug in, but we add really good fine-grained access control and high availability and scalability with spine programming cloud software development. And we do have examples of live data that we, in my AI telemetry digital twin, which is actually connected to OpenShift, Red Hat OpenShift clusters for reporting on GPU workloads and AI workloads and cloud projects using AI and also virtual machines. And this is a multi-tenant approach where we can separate different tenants and their workloads, like this NAIR project with Natural Science Foundation, where they have these 10 projects here, and show the live, whether there's any pods terminating or pods restarting or full persistent volume claims, and show them the memory usage and CPU usage of data over time. And these are metrics that are tracked in an OpenShift Advanced Cluster Management Observability tool. And so we observe this observability data and bring in all of the clusters and nodes and projects information as individual pages so that you can see the reporting on each project and each cluster and each hub and see the metrics. So this is kind of more of a live data example with fine-grained access control and statistics and things like that. And we do put these, let's see, wait, projects. We put the clusters on a map. Although I don't have access to see the clusters. So for that, I gotta, again, go to the Keycloak, apps.obs.snrk, mgspcc.org, and go to the right realm and go to my user and add myself to a group so that I can see that. And then I have access to clusters, which puts those clusters on a map here in Massachusetts. And then it shows you warning signs like these GPUs in a not ready state. So that's a concern to look at, and other metrics. So anyway, does that give you an idea of live data reporting?
Yeah, so have you thought, because digital twin actually makes sense in 3D environment, right? That is where nowadays the students are creating projects on their stems and all that. So have you thought about like maybe this would be a stepping stone when we work with some schools to, to have that kind of an approach, like build these your 2D map into 3D twins. Digital twins are basically the term used for 3D counterpart of whatever the physical space is, right?
Yes.
Yeah, so
Yeah, we are looking into it because one of the projects that's a smart village or smart city in Africa will involve NVIDIA GPUs and 3D simulations. So that's where we can actually bring it to life. It's just when you bring in NVIDIA GPUs, everything becomes super expensive because these machines together cost millions of dollars, and they're not highly available machines because I observe them very closely and see how I've seen AI workloads run them out of memory, and then they get in a state where they need to be rebooted manually. I've seen them overheat and burn up and need service. And we have a lot of issues over time. And the water cooling is very expensive and problematic over time. So with spine programming, yes, we want to get to where we're doing 3D simulations, but at the same time, most real data problems that organizations have are not three-dimensional. When you're dealing with like microchips and tiny physics of at the atomic level, then yes, the 3D simulations are very helpful. But when you're just putting things on a map, then you save yourself a lot of compute and energy costs by just keeping things two-dimensional, which has been fine for the projects that I've worked on in the past, but we are getting into that space of 3 dimensions. So we should think about what's the right way to describe 3-dimensional shapes as JSON or some other format, and how do we render that on a page? What are the best open source tools for rendering 3 dimensions on a page? And how do we integrate with NVIDIA tools to provide really advanced simulations? What do you think as well?
mm, basic approach, I have been interacting with schools. It had been their simulations itself, like they are middle school to higher school and the graduate students, and they actually have this kind of digital twin for healthcare, digital twin for their Orido projects. They make these kind of projects, right, where the STEM projects. So something they make a counterpart and do the simulations. So I have been connecting with them with the the University of Doha Science and Technology. So in those models where they use these drone or anything, drone is very specific whenever only within their farms and all they have been using. But specifically when students talk about healthcare or in that way, I wanted to understand. Basically, our model is just to create simple cubes or to place it there and understand. Like one project was cancer cells cytokinesis. So it was basically the biology students working on something. So it was enhancing the model. So it is not an IoT or anything. It is simple simulations. So, but when students actually design STEM programs based on those, IC with the chips, it can be connected to a simple 3D environment, not a very elaborate, but sometimes they can have real-time data being collected or something like that. And in that scenario, they can, enhance something like if they are working on a project on vehicles stability, or sending their prototype into ocean or something, the digital twin could be an alternative and way to gauge where the ship is or their prototype is. So this 3D prototype, our models is basically get a 3D prototype out of it whenever they are doing the projects. So these 3D prototype, when they send the signals, in a simple way, because I work with STEM students, so I just wanted to know, like, building a 3D projects, because that could be something which we can offer to the schools in the early stages, while the modules are being completed. And I think that from Dwayne's conversation, messages, I understand that you are also looking for funding in that aspect. So the QSTP has this tech fund. So if we can connect in that direction, is that something which would be of interest to you? That was why basically I'm trying to basically understand that, simple projects like a ocean cleaner or anything which they are building. Like we can use some kind of a simple project and collect, and how we can collect those, and you know
Yes, that would definitely be an interest to help solve simple problems and build up the repertoire of skills for the students, and so they can learn how to do this. That's absolutely something that we're interested in.
we don't have to create a very elaborate digital twin, like anything in a point, just like how Chris has showed in two-dimensional point representing the complete, the map of the airport. Similarly, we can just show a point or a point or a cube as a representative of the prototype. 3D prototypes will be built mostly. 3D prototype is for shape correction or something like that. The simulations works. We know that car simulations, everything is for understanding the aerodynamics, everything, right? So similarly, but in case we place this, as a data structure or collecting the data kind in the initial first stages, if we can take those, just like in two-dimensional, we have a point, we have a simple cube representing the prototype of whatever they are sending it, the project, and there we connect the data where the ocean or somewhere where they are doing it, or if it is a drone, I'm not sure whether it will be allowed, but something similar to that on a road itself, inside the hall where they do that projects. If we can connect and let them understand this digital twin space itself from a learning, maybe you can also enter into the 3D space with your spine programming, if that makes it's easy. Like we can take this. I'm thinking about how to take this conversation forward. Yeah, because I know you work with elaborate datas and data sets, but if something of this would be of interest, I think we can have another follow-up meeting or something. Yeah, if you feel that this could be something we can work together, and even we would have effectual learning would also be able to help build their data structure in this way.
Yes, absolutely. We would love to help out and make this go forward and be very successful.
Yeah. What I want to do from a technical perspective is just figure out, we looked at how PostgreSQL can store polyhedral surfaces. I want to look into how JavaScript handles polyhedral surfaces in JavaScript frameworks. And you are demonstrating something like that. Do you know the JavaScript tools you use for 3D visualizations?
Yes.
Yeah.
I built in three geometry, all the models. Yeah. Mathematics, most of my, even spring, if you, one of the simulations on spring dynamics, the entire helix is being created mathematically. So it's all, I don't model the models, like I create them, It's not that we cannot import it like a Java format. I think GLP is a JSON based export for 3D models. But when mathematically you can generate most of the 3D models, that's not a problem.
Okay.
Yeah.
So,
Thanks.
and we use plotly.js, and they have a mesh 3D surface thing.
Okay.
So I think we just need to do a little experimentation there with our digital twin to not just provide like geolocation coordinates, but an actual 3D mesh shape to something as well. And we have a way to persist it in Postgres. So I'm sure it can be done. And I think that
I'm
would be
sure,
great.
yeah.
And it will be very relevant to airplanes because an airplane is not just a dot, but it actually
Yes.
has a shape with direction, you know?
Correct.
So
Yeah.
I think that is important.
Yeah. Most of the time, simulations, even in physics concept, we think about the shapes of them, what material you have to use for that project to be built, prototype to be built, right? For an aerodynamics, like when I interact with mechanical students, it would be they are using ANSYS or something like that for their simulations. But this is something like we can come together, start from simple simulations and connect it with the digital twin. So it could be like a learning modules itself, and we can store also if we can, the student will know about 3D plus a digital, because automation was last decade. This decade is digital twin. So the students are going into that direction. So if we can, align that kind of a narrative from our end, I think that would make sense in taking this forward. Like, let me know about that. Yeah.
Yeah, we'll definitely keep in touch. Dwayne, we'll try to over the next few weeks try to create some three-dimensional design in spine programming, and if it works, we'll share with you a demo,
Yeah.
and we can.
No, if just a 3D model, even now Gemini is very capable of creating 3D model with three.js. So anything it just with prompting itself, it creates complete. It uses TSL shaders and it's very fast and all that. So if you can, if that makes sense, 3JS and TSL is quite working now. And it's very fast. Like even I can also support, because as you understand nowadays, writing code is, if you know what to be created, I think it's becoming very fast. So that way also. So it's,
Nice.
that was the one of the like students, mechanical students and all are very interested in knowing about this 3D part of it. So if we can bring in that 3D also, right? I don't want your computer to, even I don't have the budget for NVIDIA. I am looking for funding to, to maybe get some good machines. Yeah.
Nice. Okay, we'll look at 3.js and see about integrating that for our upcoming digital twins.
Yeah, and I think you said you're very interested in maybe connecting the effectual learning with the environment and environmental.
Sustainability.
Yes,
Environment.
yes, things with the environment and physics as well, in the learning.
In learning in the sense that STEM learning, it's like a connection. So just like building any prototype, students use NSS, but sometimes they don't get the understanding about how this simulations happen. There you can see that when there is a vehicle being colliding or something, how the energy transfers happens, right? But it's a quite a dense model, but we would like to use like when I interact with mechanical engineering students, they want to even understand how the load bearing, the compressibility, everything actually gets defined. So we are trying to build that kind of projects itself. When they build simple projects, their models are very simple. So we can use that to, maybe get a better understanding about how the students' analytics can be stored also, because that would be any investors looks for data. So this students analytics on their learning graphs, like how much they are getting engaged, that could maybe later on, I don't know how, because if I have a database, simple database, I can also add in some kind of a modules where we can track like whether students are interested in knowing that or not. That's a different topic. But I would like to start with the 3D projects itself, if we can take it forward. So simulation building, we can have, they are interested, prompt-based simulation creations are possible. And if we can have some kind of database also, we can actually have, just like how AI hackathons are happening, simulation hackathons or something like that can be moved in that direction. So basically that was my idea, to get the students to create the simulations.
Yeah, because I was thinking about, in industrial engineering, we always talking about, the materials and the stress that it takes over time
Mm.
and the creep, and if they can see the it taking, like on a farm, see a piece of equipment taking the stress over time, and then see it begin to break and the
Right.
stress and fracture, then they can say, oh, and maybe with the digital twin, we can say, it was 25 uses
Correct.
and it cracks normally every time,
Mm.
and then we can find ways to reinforce it and make it stronger, and and maybe that's, and maybe that's
That,
something useful on a farm,
yes, yes. And it, especially that is something with intelligence, AI intelligence, or I don't know, other they are using any other in IoT intelligence. The energy sector is actually working on predictive maintenance kind, what you are talking here. And it's a quite especially if you can connect digital twin to whatever that is, um, it's quite progressive, right? It's a progressive field. Yeah.
Mhm.
Especially
Yeah.
for the projects which I have been working with the students, or I've been interacting, I'm not working, I've been interacting with the students, are basically simple stems, and the graduate students showing interest in the building of or understanding the, so that is part their local projects for their capstone projects kind.
Okay.
Yeah.
Mm.
And I think spine programming is very relevant to students and universities to experiment on their own computer with digital twins. So
Mm.
I really appreciate your feedback on where we can go next with 3Dimensions and 3.js, and we'll definitely I take all that feedback. I love
Okay.
it when people rip my work apart, because then I can build something better for them. So yes, thanks.
Yes.
I don't know whether I ripped it, but I just wanted to give it an understanding, like, better understanding in the sense like real digital twin. The students,
Yes.
they are working in real things, right? And yeah, so digital twins by PwC, they have a big, smart city digital twins. I've seen them. No, we don't have to be like, for the students at least, it doesn't have to be so realistic, and so without breaking the machines, if we can give them something which collects the data, and they have a real time, understanding in there, that would be a step in that future of work, or something like that. I can
Yes.
approach the schools. It's very difficult to approach schools, so that was my thinking, that, yeah.
Okay. Yeah. I'm sure we'll be able to give you something
Yeah,
that,
yeah.
you can
Yes.
maximize your approach with the schools. Because do they have any type of curriculum that's attached with what
Uh, it's-
with the from intro to intermediate to advanced learning in
no,
this, or
this STEM, actually they all wants to be, participate. So that is like it's beyond curriculum also. So when we talk, that's another problem with schools. So we have to align with, but when we talk about STEM week, STEM project, STEM fair, it comes like beyond, it is what you call on top of, a layer on curriculum. So every school kind participates on that time. And
Okay.
they connect with even in US they have this STEM fair. They want to participate there. They have in Malaysia. They want to participate there. So it's beyond curriculum kind. So
Okay.
that's where I'm trying to interact with and get, in case it's possible.
Okay.
Yeah.
Okay. Awesome.
So any farming, even aquaculture, they can have a digital twin similar to them. So that kind of in projects itself, we can promote it.
Okay. Well, we will, we'll continue to dialogue and figure it out and make sure that we, able to, meet your needs.
Yeah, need can evolve. If you can figure out something else also, so the modules are there. I have to give them the students, schools. I'm trying to, some schools ask whether they can, take these modules and have it in the local drive and all. But I have to still work on, I'm still trying to get the funding from QRDI in that direction. So hopefully then I can reform the modules also, 3D modules. But if I can have something connected with the backend data, if that makes sense, that also would be very good. If in the
Yeah.
learning itself, the connecting learning analytics, if that is so.
And like if you have a list of your modules,
On an
and
Excel sheet I have. Yeah, I
okay,
have that. Yeah. But
but yes, getting funding, we'll that's something we love to help do. So we'll that's yes, that's very important.
yeah. And apart from that, I have two interns, like my intern working on knowledge graph, like so. You have an AI interface. The student comes into our platform, and the AI will help them to connect this, because we talk about STEM. Physics is not just physics. We would like connect it with the cell, the fuel cell which they are using or something like that. So it will be a complete STEM modules kind, physics, chemistry, mathematics, and even here there when I think when Chris will build the model, he'll understand that there will be different kind of way the like a rocket can go through a linear motion, or quadratic motions and all that. So how do they differentiate, get the distance, get the velocity, acceleration, everything out of it, the distance time graph and all that. So these are something we have been like distance time graph is been simulated. Those are available as simulations. But if something like that also, I don't know where I was going with this, but yeah, so something like that also we have been, it would be interesting.
Yeah. Oh, Chris is sharing an example of a 3D simulation.
Okay.
Yeah, we'll try.
Simulation of plane on a map with 3JS. You have already done it.
Somebody's already done it, so we just need to
Yeah,
follow
I
their
know.
pattern, because it shows the
Yeah.
planes like going.
And 3JS community is quite, supportive in that. When I was building in 2021, I used to remember anything, there would be someone who would have already answered the question.
Yeah. All right. We'll plug into
Yes.
that community
Yeah.
and
Yeah.
Yes.
Are there any types of recommended physics books that the school is using so we can,
Um,
or what?
Physics. Physics, normally open source physics, like
Everything's open source.
lab
Okay.
text, open source like text physics and all, nothing, it's almost the same. But
Okay.
connecting, and when I talk about STEM, which is an interdisciplinary approach, that is what is, more I'm targeting, especially with the schools, which is, those who have curriculum, they already get something from Macmillan or and they don't want, I thought, another third party. So I would like to connect with those schools which are more open to this, like AP syllabus and all that, which has,
Okay.
Wow, this is really, someone has already built it. I remember they were talking about Google Earth, everything. I've opened it. It really looks like giving it out as a project. It's not a difficult thing at all. Yeah.
Yeah, but hopefully with spine programming, we can come up with
A
very
database.
new and unique
Database.
scenarios. Yeah, with
Um,
database driven, API
yeah.
and database driven, also
Yeah.
access control, because this is like a publicly accessible digital
Uh,
twin, but we can control access to it. We build an API for it that's data driven with the database and also searchable to add new capabilities and security. So this will be fun.
And it loads. It didn't take much time to load anyway. That's what I figured. I've been in call, right? And I've opened the phone port. It was not that slow. So
Yeah, we can do it.
Yes. Okay. Well, we want to thank you so much for your time, and we're going to work on this and get back to you in a little while, so we can continue this and make sure we can help you with effectual learning.
yeah, sure. If you need anything, like, let me know. Hopefully, I can take this forward. That's what I look for. Have a nice day. Yeah.